The study talks about the role of remote sensing in damage assessment due to flooding. It also covers the different GIS softwares and how they are used to establish a methodology for SAR data utilization during typhoons. The study is entitled Rapid Detection of Inundated Area in Camarines Sur during Tropical Depression Usman using SAR data. Around 20 typhoons enter the Philippine Area of Responsibility or PAR each year. 9 of them pass through and bring damage in the country. Usually, it happens during the wet season from July to October. According to Pag-asa, it is a tropical depression if the maximum sustained winds is up to 61 kilometers per hour. In December 2018, Tropical Depression Usman devastated the country. The damage in agriculture amounted to 1.94 billion pesos. Here are some of the pictures of the flooded agricultural area in Bula, Nabwa, Baaw, Iriga City, Milaor, and Libmanan, Camarines Sur. Given the innovation in technology, what can we do and what is needed? We need a near real-time method in determining the flood extent during disasters. Farmers always have their ever-reliable carabao which helps them in their farming activities such as plowing the field. With new technology, there is one up above that can be his farming aid. This is the satellite. Utilizing these satellites is necessary to give us information and better understanding of the status of our field. It can also be done with the help of SARAI Enhanced Agricultural Monitoring System or SEAMS. We have hundreds of satellites revolving around the planet. These satellites gather information regarding the land, sea, and atmosphere. They collect data every now and then depending on their revisit time. Accuracy can be based on their spatial resolution. In our concern, we have to maximize this information for the benefit of agriculture. One of the satellite data that we use is Sentinel-1. It was developed by the European Space Agency and it is an all-weather synthetic aperture radar or SAR. All-weather means that even if there are rain or thunderstorms which make clouds visible, the data is not affected since the radar can penetrate these clouds and therefore can give us accurate data despite the weather condition. For processing the satellite data, QGIS is a program commonly used. It is a free and open source cross-platform that supports viewing, editing, and analysis of spatial data. It is easier to download on the internet and different plugins are contributed by different experts around the globe. Traditionally, satellite data are downloaded per tile. Each tile is around 1 GB, taking about more than an hour to download. Google had an agreement with different satellite developers to store their satellites' information in a data catalog. Google developed an online platform which stores satellite images and lets users analyze geospatial information through JavaScript coding. It is called Google Earth Engine. With Google Earth Engine, 1 hectare of supercomputers can process the data fast in series. Google also has a cooling facility for their supercomputers. The main objective of this study is to produce a near real-time methodology that can easily map and estimate the extent of flooding during TDUsman. The specific objectives are to know the flooded municipalities and determine the affected rice production areas. The chosen area was Camarines Sur with about 526,682 hectares of land consisting of 2 cities and 35 municipalities. The province produces rice in most of its areas. For the methodology, we have 3 parts: data acquisition, pre-processing, and area computation. For the data acquisition, first, the available Sentinel-1 data after the typhoon was identified. It was determined to be December 29, 2018. Then the single copolarization vertical transmit and vertical receive band was chosen since it is used to detect water bodies. Lastly, the interferometric wide swath instrument mode was used to filter the image. This is the main operational mode that satisfies most current service requirements and avoids conflict. The pre-processing was done in Google Earth Engine with JavaScript codes developed. It was then visualized the backscatter between -25 to 0 using the palette blue, white, and black. The threshold for water bodies was also determined, and from there, the flood mask was extracted and exported. The area computation was done in QGIS. The exported flood mask from Google Earth Engine was opened in QGIS. It was overlaid with the production area mask processed using the long-term Landsat 5 data through unsupervised classification. Upon overlaying, the flooded agricultural area was determined for each municipality. For the results, the images show the backscatter data from Sentinel-1. The blue areas are water. The threshold for water bodies was determined to have a backscatter value of less than -12.5 decibels. The flood extent was determined and estimated flooded area was 34,403 hectares. On the other hand, the flooded agricultural area was also computed and found to be 28,175.15 hectares. The corresponding flooded municipalities were identified and 27 out of the 37 localities were flooded. The flooded areas in hectares can be seen in the table presented. Also, the maps for each municipality can be viewed. The green areas are the agricultural areas where the flooded areas are shown in blue. In order to understand the reason why the said municipalities were prone to flood, the elevation map in Camarines Sur was processed using the data from Advanced Spaceborne Thermal Emission and Reflection Radiometer or ASTER. As you can see in the image, areas near San Miguel Bay show low elevation. Looking at the three-dimensional view of the elevation model at flooded condition, the increase in river height will affect the municipalities in Cabusao, Canaman, and Calabanga. Continuous rainfall with high intensity may lead to more areas being flooded. For Tropical Depression Usman, the rainfall intensity was about 21.69 mm per hour. It is important to take a look at the status of vegetation. The most common way is through analyzing the Normalized Difference Vegetation Index, which describes the greenness and density of the vegetation. The value ranges from -1 to 1, where low values of less than 0.1 corresponds to water, snow, and ice. Moderate values depict barren land and shrubs. Meanwhile, high NDVI values show dense vegetation and can be usually observed during the peak vegetative stage. It can be computed based on the formula NIR minus red over NIR plus red. The NDVI curve of Camarines Sur can be seen in the figure. There are two curves observed which show two cropping seasons. For the dry season, it is from mid-December and early May. On the other hand, the wet season is from mid-June to November. Based on the NDVI curve during TDUsman, the agricultural areas were on their maturity to initial stage during the dry season. For those crops ripening during that time, there is low yield loss if the areas were 1 to 2 days submerged. However, if the agricultural area was submerged to 3 to 4 days, it may cause an estimate of 10 to 15% yield loss. For those on the tillering stage, 10% and 15 to 20% yield loss can incur for 1 to 2 days and 3 to 4 days submergence respectively. As reported by Camarines Sur Provincial Agriculture Office, the total rice area damaged by TDUsman was 28,545.5 hectares, amounting to 934,030,920 pesos, affecting 24,890 farmers. Since the damaged areas were still at the initial stage, there was a great chance of recovery. However, for those municipalities with rice in maturity stage, there was a decrease in yield. As stated by the Provincial Agricultural Office, the production before the calamity was 4.1 tons per hectare, but after the devastation of TDUsman, the production became 2.56 tons per hectare. In conclusion, the process of deriving flood mask by utilizing single polarized SAR is useful for damage assessment. Based on the positive results of this study, affected areas can be estimated days after the disaster. One of the limitations of this study is that SAR detects wet areas, even zones in land soaking stage, and classifies them as part of the flood mask. It is recommended that field validation should still be done. With its great potential in the development of smart air agriculture in the country, adapting SEAMS through training and capacity building is recommended for the dissemination of flood maps nationwide.